In this video, we will be talking about finding relationships among variables. When we conduct research, one of the most commonly used terms in talking about relationships between variables is the word correlation. And a lot of times it is misused. In today's lecture, we will talk about what correlation means and when it can be applied between two or more variables. So correlation assesses whether or not two variables are related. It is a quantitative measure, and usually that is denoted by what is known as the Pearson correlation coefficient, R. So, what am I trying to find out? I'm trying to find out if my weight is related or correlated to the amount of food I consume. I'm trying to find out if weight loss is correlated to the amount or time spent exercising. One of the things you will notice about correlation is that it is best applied when you are looking at two or more continuous variables, meaning variables that can be measured using a decimal, or we say that it is continuous, meaning it can be represented as a fraction. There are other tests that we will talk about when it comes on to understanding or testing relationship between two or more variables. But the most basic of them all is to check first to find out if there is a correlation between the two, or between two or more variables. So do variables change together in a predictable fashion? On your screen, we have a graph, and this graph represents on the x-axis and on the y-axis the relationship between VO2 max, which is a measure of fitness, cardiorespiratory fitness, and distance traveled in a 6-minute run. So we're looking to see if your VO2 max is influenced or correlated to the distance traveled in a 6-minute run. What we can realize is that as variable 1 increases, variable 2 also increases. This is an example of what we would call a positive correlation. As your VO2 max increases, then the distance traveled in 6 minutes also increases. In other words, your level of fitness is directly correlated to the distance traveled in a 6-minute run. So the higher my level of fitness is in terms of my cardiorespiratory fitness using VO2 max as a measure, the higher the greater my distance run in 6 minutes is going to be. We now take a look at the very same two variables, but this time we're looking at time on a 1-mile run. And what we're seeing is that as we look at this scatter plot, and this graph is referred to as a scatter plot, make a note of that this is a scatter plot between VO2 max and time on a 1-mile run. What we realize in terms of the direction of these points, which represents individual measurements, is that they are sloping downwards. So what we can see is that as variable 1 increases, variable 2 is decreasing. So what we see is that as VO2 max increases, time on the 1-mile run decreases. So higher level of VO2 max is associated with lower time on, or decreases in time on, the 1-mile run, hence representing what we have here as a negative correlation. So the lower the VO2 max, as you can see down here, it would represent a higher time or better time on my 1 mile run. That's essentially what this is showing, a negative correlation. Apart from looking at the direction of the correlation, which is what we do when we use a scatter plot, we want to look on the strength of the correlation. To look on the strength of the correlation, we need to do much more than a scatter plot. And so we do what is known as the Pearson correlation test. And the Pearson value of R ranges from 0 to plus or minus 1. 0 represents that there is no relationship between the variables, and a positive 1 or a negative 1 represents a perfect relationship. Here we have a strong relationship, which is positive, and here we have a negative, a weak relationship, which may also be considered as positive, but this is a weak relationship. How do we know for a fact that the relationship is strong or weak? Again, we know this by looking at our Pearson correlation coefficient, which is represented by R. And we'll talk some more about the R and the R squared in a little while. So what is the relationship between variables in a positive correlation? As one variable increases, the other variable also increases. And in the negative correlation, we are suggesting that as one variable increases, the other one decreases. While we can say that a relationship with a R of 0.75 is a stronger one compared to a 0.7, let me rephrase that. So is a relationship of negative 0.75 stronger or weaker than one of 0.70? And the answer to this is very straightforward. Notice that the two values are around about the same in terms of value. However, one is negative and one is positive. Again, remember the scale goes from 0 to plus or negative 1. So what this is indicating is that there is no difference in the strength of the relationship because the two values are almost the same. One represents on the other side a negative correlation and the other a positive correlation. So how do we interpret R and what R means? So given that R is significant, and we will know if R is significant based on the output from our SPSS, which we'll go to in a little while, we can determine how strong the association is between the variables. So for example, if we have an R of 0.4 versus an R of 0.5, both can be significant, meaning that the P value is less than an alpha of 0.05, but one is stronger than the other because, as you can see, one is closer to the number 1 compared to the other. We also calculate what is known as the coefficient of determination, which is the square of our R. So this represents the amount of variance in one variable explained by the variance in another variable. So any variation in my VO2 max, my cardiorespiratory fitness, is explained by the variance in my time on a 6-minute run, meaning that the two variables are really and truly correlated given that they are explaining a lot of the variance in each other. So the higher value the R square is, whether negative or positive, and usually you'll find that the R square is only going to be positive because a negative number squared, which is a negative number multiplied by itself, ends up giving you a positive number. So the higher that R square value is the more of that variance we're saying is being explained by one variable in another. So higher values will indicate a stronger relationship. So now we come to what you'll see on a SPSS output when you do a correlation test or correlation analysis. You will find that in this example, we are looking at high school GPA and college GPA, and we're looking to see if high school GPA is correlated with college GPA. In our Pearson correlation coefficient test, we look and we see that our correlation value is 0.8. So take a look at that. This is 0.8, which is a positive number, and it also indicates that this is a strong relationship. The next thing we want to find out is if this is a significant relationship. And we look at our significance value, which is a p-value of 0.01, and because this is less than 0.05, we say that this is a significant, strong, positive relationship between high school GPA and college GPA. So very important to note that when we look at the correlation analysis, we want to look on the direction, whether it is positive or negative. Secondly, we want to look at the strength, how close it is to plus or minus 1. And then we want to see if this relationship is significant. And so we look at the p-value and compare that to an alpha of 0.05. Here we have a table that explains the jargon or the interpretation of both R and R squared. And this is something that it is useful for you to commit to memory, indicating what means that a relationship is very strong, what means that a relationship is strong versus moderate, weak, or very weak. So the R squared is interpreted a little bit differently from R. R simply tells us if the two things are correlated and whether that correlation is strong or whether that correlation is weak. The R squared goes beyond that in that it is the coefficient of determination that tells us how much of the variability in one variable is explained by the other. And therefore, if you have a very high R squared, it suggests that the relationship is very strong. The coefficient of determination is the same as our R squared as just explained. And a relationship between two variables can be significant but not meaningful. What does this mean? It means that we can have a R value of 0.4, which is not really strong, but it can be significant, meaning that the p-value is still less than an alpha of 0.05. So you can have significant relationships that are not meaningful. Okay. In order to do this on SPSS, meaning in order to run your own correlation analysis, you will need to watch the SPSS correlation video before doing your practice questions as well as your worksheet. So look on the next two slides. You will see some examples that I've given for you to do on your own, and you will need to watch the SPSS video for this. So here we have a sample of children. We have their age and we have their weight, and in essence what we want to find out is if age is correlated to weight. And there are a few questions that you must answer specifically